There we go. All right, guys. What we're starting today is chapter 7. So we're going to be starting chapter 7 today, which is going to be talking about rational functions. Now, we're not going to delve too far into rational functions in our first section here, 7.1. What we're mainly going to be talking about today is direct and inverse variation. Now, you've learned the two variables x and y show direct variation when y equals a of x for some non-constant a. So when we talk about direct, and you can write this on the page, y is equal to a times x. This is direct. And a is just a number. It's just going to be some constant number, some constant term. And I will sometimes switch out a and k, because you'll see it as y equals ax or y equals kx. Because a and k, it's just a number. It's just a constant term. Now, another way we can look at this is if I divide both sides by x, I would get y over x is equal to a. And this one here is actually helpful. Y over x equals a. That means if it is a direct variation, if I take y divided by x for any set of numbers or any set of terms, it will give me a constant number. And when we're talking about direct variation, we're saying that x varies directly to y. As x increases, y is going to increase as well. Now, if x decreases, what's y going to do? Decrease. They vary directly. As one changes, the other changes proportionally as well. They go in the same direction. Now, that's direct. Now, inverse, two variables x and y show inverse variation when they are related as follows. Y equals a divided by x, where a is not 0. Now, what do we think about inverse? What's going to happen with x and y when it's inverse? So if x increases, y is going to decrease. Now, if x decreases, y is going to increase. Now, we can do the same thing that we did with x, how we had x and y on the same side. And instead of, so for this here, instead of dividing both sides by x, we can multiply both sides by x. And if we do that, we get xy is equal to a. I'm just getting x and y on the same side. That means if they vary inversely, they're an inverse variation. If I multiply the x and y terms together, they will give me a constant. Because if something varies directly or inversely over a set of terms, that constant of whatever they're increasing or whatever they're decreasing by will remain the same across everything. Now, looking at these here, inverse and direct, can anybody think of an example that would be considered a direct variation, kind of something that we deal with in everyday life or kind of you've seen? Two things that vary directly. I was just saying, like, if we think of a real world example of direct variation, what would that be?
More money, more inflation.
So money and inflation, because as money inflates, the actual value or how much it's worth, or kind of how much money you would need to spend would go up.
Yeah.
That would be more inversely, because inflation, because if we talk about inflation, as inflation goes up, the value of the dollar goes down. You need more of it to work. So that would be an inverse variation that does work. How about products? If we talk about products, the supply, or that would be inverse also.
Fish swim. Goldfish swim. So therefore goldfish are fish.
Not so much. I mean, that'd be a. It's direct, but when we talk about direct variation, as one value increases, the other value increases as well. So we're talking about something increasing. So yes, if the rarity of something increases, it's. There you go. Would go up. Now, if the rarity went down, the value would go down as well. And this is really what we're talking about with direct and inverse. Because direct is going to be going in the same direction. Either they both go up or they both go down. Sure. Mm-hmm.
Why don't we make diamond armor and just go to war?
Because cost and quality would be way too expensive.
You could give it to people. That way then we get headshots.
All right, let's get back to this here. So when we look at this first example, what we're going to do first here is determine and classify whether x and y show direct variation, inverse variation, or neither. Now, with direct variation, we saw it in two forms. We saw it in the form of y equals ax, or y over x is equal to a. And x and y can be really switched in either way, because we can have x is equal to a times y, or x over y is equal to a. It's just a constant term. Inverse, we saw it in the form of y equals a over x, or yx equals a. And then neither would classify, it wouldn't match up with either one of these. Now, if we look at the first one, a, how would we classify this? X times y equals 5. Why would it be inverse? Because it is.
I thought there was going to be like more fundamental reason behind this, mostly because the formula x will be a.
Right, because x and y, I mean, we multiply them together. I could rewrite that, because we could divide both sides by x and get it in the form this here. Or it matches up with our x times y, or y times x equals a, equals a number.
I wanted to say it's inverse, but I thought that was way too.
Okay.
It was direct. I thought it would be like direct inverse of the either. So.
How about the second one? Letter B. Y equals x minus 4. Okay. Anybody agree or disagree?
Besides the two lines. I'm voting B is direct.
Okay. Inverse? Okay. So what are we saying? Why are we saying direct? So why would we say direct?
Because it looks really simple to do y equals x times a.
We just have the minus, right? So,
Whoever uses ever saying that they're at multiplying, I thought it would be 80 over 5.
so did we talk about addition and subtraction yet?
No.
So could they have addition or subtraction?
Yeah. Until things found, anything is possible. So, yeah.
Oh my grade.
Is it either?
Because it is neither. Because these here, when we talk about inverse, direct and inverse variation, they're either both increasing or both decreasing by a set value.
Oh yeah, x is always the one.
Mm-hmm.
Well, I vote.
So really, when we talk about addition or subtraction, or really anything besides multiplication or division, it's not going to be talking about these variations. Yes? All right, let's look at letter C. Y divided by 2 is equal to x. Y divided by 2 is equal to x. What do we think with this here?
Random question. Divide the y out of that.
We could. We could divide the y, but would it be easier to move the x and y together or get the 2 away? Because I couldn't multiply both sides by 2, yes? And what happens to this 2 and 2 over here? They cancel out, leaving me with what? Is let's do it the other way. Let's do it the way you were saying. So I'm going to erase this here. So let's say we divided both sides by y. So, and this is a little bit weird because y and y would cancel here, yes. But what that leaves us with here is 1/2 is equal to x over y. Now, this does work because here in our direct variation, we do have y divided by x divided by y, that's fine, equals 1/2. Now, is 1/2 a number? So this here, so we divided by, we get x over y equals 1/2. So it still works because we still have those variables, x and y, being divided, working together, equals 1/2. Now for our formula, we had y divided by x equals a. And a is just a constant term. It's just a number. And because we still have it in that form, x and y are just flipped, it still works.
So you can't.
Yeah, you can flip them.
That's what I was asking.
Because if we flip it, because we talked about this sometimes with fractions or ratios, because if I flip one side, I have to flip the other. Well, if I flip it from y over x is equal to a, if I flip this and have x over y, well, over here I'd have what? 1 over a, yes? Well, 1 over a is just a fraction, isn't it? It would just be a number, right? Is a, because a is a constant, it's just a number, right? So would, well, 1 over a would be the same as just a. That's one of the marvels of constants, because we're still just talking about a being a number, yes? It's just gone from 2 to being 1/2. Well, 2 and 1/2 are both constants, yes? They're both numbers. So we can just still define it as a. Essentially, that 1/2, that division, that variable, that constant term will suck it up. It's the power of constants. They're crazy like that. They can suck up negatives too, because if it pulls the negative inside, the value of a changes, and we can, when we solve for it, if we solve for it, it would take it out. It would take its place. Above and beyond what we normally cover, but constant terms are.
I don't want. I couldn't afford enough.
Yep. Well, let's look at these here. Huh? Yep. Let's look at these three here. So 6x equals y. Would that be direct, inverse, or neither? This would be direct, because our main definition for direct variation is y equals a times x. And in this case, a is 6. How about number 2? I would agree. Because again, when we look at these here, well, one of our inverse, the way we wrote it, was x times y is equal to a. Here we have x times y is equal to negative 0.25. Well, negative 0.25 is our a, so it's just matching it up with this here. Questions on this here so far? Okay. How about number 3? Because it has addition. x plus y equals 10. Last three here. Which one out of these three do we know for sure? What about B? B is what? Because we know if it has addition or subtraction in it, it's going to be neither. It's not direct or inverse. So let's go on after that. Let's look at A. X times y equals 17. It would be inverse. Is when they're inversely related, it works out that x times y, those two values multiply together, will give us constant. And lastly, C. It is direct. I mean, besides all these so far, I've given us one of each on each of these here. Because it looks like it could be inverse, because we have y divided by 10, yes? But isn't this the same as 1/10 y equals x? Because we're just multiplying by y by 1/10. Now, we could have also multiplied both sides by 10, because 10 and 1/10 would cancel out, leaving us with y equals 10x. And that's a little bit easier to see as direct, because we could solve it for y. But it is direct. Okay. Tell whether x and y show direct, inverse, or neither. Direct variation, inverse variation, or neither. Now, for some reason, because we had it in our form y equals a times x and y equals a divided by x. Because for direct, we had it as y equals a times x. Now, for some reason, I wrote it as y divided by x is equal to a. And for inverse, for some reason, I rewrote it as x times y is equal to a, yes? And what this is saying is that for direct variation, when I take the value of y and divide it by x, I get a constant, yes? Because a is a constant term. And if for inverse, if I multiply x and y, it equals a, which again is a constant, yes? So if I had a direct variation set up and I took y and divided by x for the whole set of numbers, what should the a be? It should be constant, yes? Because it's a constant term, it should be the what? Something's constant, it is the same, yes? So we should have the same value across every single term, every single set of numbers, yes? So if here for letter A, these sets of numbers, 2, negative 12, 4, negative 6, 6, negative 4, and 8, negative 3, if it's direct or inverse, the constant a, that a term should be the same for every single set of numbers, yes? And it should work out that way. So if I want to see if it's direct, well, I can take the values of y and divide them by the values of x. So our first set would be what? Negative 12 divided by 2. And what is negative 12 divided by 2? Okay. Negative 6 divided by 4.
Whatever it is, not negative 6.
Well, it's not going to be negative 6. No, it's going to be 1.5. Well, those aren't the same, are they? So if it would be direct, these values would have to come out to be the same, yes? So it's not direct. Okay. I'm going to erase it so that I have a little bit more space. So next we can try inverse. And what would I do with inverse? I would times them. So we can do 2 times negative 12, which would be negative 24. Okay, that's 4 times negative 6. What's 6 times negative 4? Well, 4 times negative 6 is negative 24. So 6 times negative 4 should be. And lastly, 8 times negative 3, which is? Well, did we get the same value all the way through? So this here would be what? Now, if we don't get the same value across all three, or all the terms, all the numbers, then it would be neither. Because if we divide and we don't get the same number, and we multiply and don't get the same number, then it's neither. So let's look at these here. So we can divide first. So I can do 2 divided by 1, which is 2. 4 divided by 2. I mean, we're good here, yeah? I mean, I've got 2, so this should be, what, direct, yes? I don't have to go any further, right?
No, you should.
Why are you saying I should? Oh, well, that's 2 and 2/3. So I would definitely make sure to check every single number. Just because it looks like there's a pattern that's working doesn't mean that there always will be. Hint, hint, especially at the test. Because they might throw in, I might throw in 4 that work and then the 5th one doesn't.
Well, that'd be funny. That's funny.
Yeah.
I'd laugh. I wouldn't mind missing that one. That would be funny.
So it's not direct, so we can try inverse, so multiplying them together. 2 times 1 is 2. 2 times 4 is,
Wait.
so this is what?
Neither.
I thought we were doing anything.
So when we divided them, they didn't all work out to be the same number. And we only had to try 2 with multiplication, and we found out they're not the same number. Is as soon as they differ, as soon as one of them differs, we get a different value for our constant term, we can stop there. Because again, the constant has to be the same all the way through. All right, let's look at number 4. So I'll start out with just dividing. So 20 divided by negative 4 is negative 5. 15 divided by negative 3. Okay, well, we learned from the last one, we can't stop here. 10 divided by negative 2. And 5 divided by negative 1. So this here would be what? You're good. Direct, because it's kind of misleading. Because when we're checking these here, determine if it's direct, we're dividing. If we want to determine if it's inverse, we are multiplying. It's a little backwards. So making sure that you have those original formulas that we did down is good, just as reference and kind of looking back. But kind of making sure what we're doing. Okay. Let's look at number 5. Now, we don't always have to start off with direct. We could start off with inverse or direct. It doesn't matter which one. Now, looking at these numbers here, well, x is 1, 2, 3, 4. Y is 60, 30, 20, 15. What do we think it could be? Inverse. Because what is inverse? What happens with inverse? As one increases, the other decreases. They're going in opposite directions, yes? Are the values of x and the values of y going in different directions? Well, the values of x are doing what? They're going up. The values of y are going down, yes? So this here, if it was going to work, we'd hope it to be inverse. Now, to check inverse, we do what? Multiply them together. So we would do 60 times 1, which is Well, 60. Then we would do 30 times 2, which is, and then we would do 20 times 3, which is 60. 15 times 4 is, and
Why,
this,
so you said it has to, when x increases y, has to go down. Why didn't they do it on a? Because they both.
because, let's look at it. So this here goes, because this is getting to be a bigger positive, yes?
Right. It's decreasing.
It's decreasing to a smaller negative.
How does it affect it?
Because as this is increasing, the other is technically, yeah, it's just the negatives are a little tricky. Negatives are a little tricky that way.
I already dislike this. But it's fun. Well, it's okay.
Because I feel like we're pretty good on these here, yes?
Now I remember these.
Yep.
I remember these.
The variables x and y vary inversely, and y is equal to 4 when x is equal to 3. Write an equation that relates x and y. Then find y when x equals negative 2.
Write your own formula.